All right, let's talk Kubernetes on AWS. If you're a cloud engineer, you know this is a huge topic. So today, we're going to cut right through all the noise and get to the fundamentals of running Kubernetes on AWS using EKS. Let's just dive right in.
I mean, really think about that for a second. Sure, we can all launch an EC2 instance. But what happens when you need hundreds? What happens when one of them just dies in the middle of the night? Or what about when you get a massive traffic spike and you need to scale up instantly and then scale right back down so you're not burning money? See, this is exactly the kind of chaos that Kubernetes was built to handle. It's all about orchestration, making sure your apps are resilient and automating the whole shebang. So before we can even get to the cool AWS-specific stuff, we all need to be speaking the same language. Let's quickly break down the absolute essential building blocks you'll find in any Kubernetes environment.
First up, we have the cluster. The easiest way to think about a cluster is that it's your entire playground. It's the sum total of all the computers, all the CPU, all the memory, all the resources that Kubernetes gets to control to run your apps. It's the whole thing. Now, every cluster needs a brain, right? In Kubernetes, that's the control plane. This is the master intelligence of the whole operation. It's constantly watching everything, making all the big decisions, like where to place your applications, how to respond if something breaks. It's the central nervous system, the boss. And well, if the control plane is the brain, then the worker nodes, they're the muscle. These are the machines, your EC2 instances in the AWS world, that are actually doing the heavy lifting. They're the ones that run your application containers. The brain tells them what to do, and the muscle gets it done. Simple as that.
Okay, now this next part is really, really important. In the Kubernetes world, you don't really deploy containers directly. Instead, you wrap them up inside something called a pod. A pod is the smallest, most basic thing you can deploy. You can kind of think of it as a little wrapper or a little environment for your container. It represents a single running instance of your application.
Okay, now that we've got those basics down, let's bring AWS back into the picture. Here's the deal. Running that brain, the control plane, is incredibly complicated. I mean, it has to be secure, it has to be highly available, you have to patch it. It's a huge operational headache. And that is exactly where Amazon EKS comes in. It's basically the easy button for that very specific, very hard problem. And this right here, this is the core value of EKS. AWS takes on that massive, massive burden of installing, scaling, and maintaining the Kubernetes control plane. They worry about its availability, its security, all of it. And that frees you up to focus on the thing that actually matters to your business, your applications. So this brings us to a really critical idea for any engineer who's going to use EKS. You have to understand who's responsible for what. So let's take a look at this shared responsibility model in action.
It's that same brain versus muscle analogy. On the left, AWS manages the brain. That's the API server you talk to, the critical database that holds the state of your cluster, the scheduler, all the patches and upgrades. And on the right, that's your job. You manage the muscle. You provision the EC2 instances for your worker nodes. You deploy your application pods onto them, and you're responsible for configuring their networking and their security with IAM.
All right, theory is great, but let's make this real. How do all these pieces actually come together to get a web app running and visible on the internet? Let's just walk through it. So first you create what's called a deployment. You just tell Kubernetes, hey, I want 3 copies of my web app running at all times. That's it. The control plane, the brain, sees that request and automatically finds space for 3 pods on your worker nodes. But here's the catch. Those pods can be deleted and recreated anytime, so their IP addresses aren't stable. To fix that, you create a service. Think of it as a permanent address for your app. And now for the magic part. Because you're on AWS, EKS sees that this service needs to be reachable from the outside world, and it automatically creates an AWS load balancer for you to route traffic right to your app. Okay, we've covered a lot of ground. So as we start to wrap this up, let's boil it all down to 3 core mental models. If you can just get these 3 ideas locked in your head, you'll have a really solid grip on EKS. First and foremost, EKS is a partnership. It's a really simple equation. AWS provides the managed control plane, the brain, and you provide and manage the worker nodes, the muscle. This division of labor is the entire reason the service exists. Second, you've got to train your brain to think in terms of pods. In this new world, we're not so much managing individual containers or EC2 instances anymore. The pod is the fundamental atom of the Kubernetes universe. It's the smallest building block that everything else is made of.
And finally, number 3. Remember that pods are designed to be temporary. They can be created and destroyed all the time. Services are the answer to that potential chaos. They give you a stable, unchanging network address, so the rest of your system always has a reliable way to find your application, no matter what's happening with the individual pods behind the curtain. So let's just recap real fast. EKS handles the complicated brain for you. You are responsible for the muscle, the worker nodes, and your apps. The way you work is by telling Kubernetes what you want, your desired state, using things like deployments and services. Then Kubernetes does all the hard work to make that a reality. It's a totally different, declarative way of thinking. And at the end of the day, this is the goal. This is the whole reason we use services like EKS. It's about taking your engineers' valuable time away from things like patching operating systems and worrying about control plane uptime, and letting them refocus that energy on building the applications and features that actually matter to your customers.
So there you have it. We've gone over the core concepts, the division of labor, and how all these pieces fit together. You've got the building blocks now. The only real question left is, what are you going to build with them? Thanks so much for joining me.